Student, this is a question number 8 from chapter 2 of HC Verma. Carom board has the queen at the center. Okay, so this is your carom board and there's a queen kept at the center. The queen, hit by the striker, moves to the front edge, rebounds and goes in the hole behind the striking line. So queen goes like this, rebounds from here and goes back into the hole over here. So we have to find the magnitude of displacement of the queen from the center to the front edge, from the front edge to the hole, and from the center to the hole. So let's draw the path of the queen. The queen would first go in this direction, then rebound from here and go to the hole like this. Correct? Now you could apply. You could say that laws of reflection are applicable over here. You could apply that. So if this is a normal, then this is your angle of incidence, this is your angle of reflection, then they should be equal. That means this angle is 90 minus I. If this is theta, then this angle should also be theta. Now we construct a triangle over here. I drop a perpendicular over here, right? Now look at this triangle and this triangle. Both the triangles have a 90-degree angle and have the same angle theta. Therefore, both the triangles will be similar to each other. Okay. That means now if I write this as L1 and this as L2, then this length as x1 and this length as x2, then I can say that since the triangles are similar, x1 by x2 should be equal to L1 by L2. Now in the question, the carom board is 4 feet by 4 feet. So basically L2 is equal to 4 feet. Okay. And since the queen is initially kept at the midpoint, so this length should be half of L2. That means L1 should be equal to 2. So the ratio over here L1 by L2 should be equal to 1 by 2. Okay. That means 2x1 equal to x2. So in the diagram over here, I'll replace x2 with 2x1. Now, what is this total length? X1 plus 2x1, that is 3x1. But at the same time, since this is your midpoint, okay, so from the midpoint to the edge, your length should be half of the total length of the carom board. That means this length should again be equal to 2. So x1 plus 2x1, that is 3x1 equal to 2, or x1 equal to 2 by 3 feet. Okay. Now coming to the question, we have to find the displacement from the center to the front edge. So from the center to the front edge, this would be your displacement. So how do I find this hypotenuse? I use the Pythagoras theorem. I have this right angle triangle, right? So the answer to the first part will be, answer to the first part of the question will be root of L1 square plus x1 square. Correct. L1 square plus x1 square will give me a square of the hypotenuse. So that is root of L1 is 2 square, x1 is 2 by 3 whole square. So this will be equal to 2 root 10 divided by 3 feet. Now talking about the second part. In the second part, they are asking from the front edge to the hole. That means from the front edge to the hole, they are asking this hypotenuse of this right angle triangle. So for this right angle triangle, I can apply Pythagoras theorem and my hypotenuse will be under root of 2x1 whole square plus L2 square, right? 2x1 squared plus L2 squared. I'll get the resultant hypotenuse. So this will be equal to root of x1 is how much? 2. So 2x1 is 4. 4 square plus L2 is also 4. 4 square. I'm sorry, 2x1 will be 4 by 3 whole square, right? So this will be equal to 4 by 3 root 10 feet. Now coming to the third part, from the center to the hole. From the center to the hole, I want this diagonal. So that's very easy to calculate. I take this line and this line. So this side will be half of the edge. So this is equal to 2. This side is also half of this. So this is equal to 2. Then this hypotenuse will be how much? Root of 2 square plus 2 square. So this will be root of 2 square plus 2 square. That will be 2 root 2. Clear? Feet.